Okay, let's solve this center of mass problem for you. You got this dog, weighs 10 pounds, standing on a flat boat, 20 feet from the shoreline. He's going to walk 8.5 feet on the boat towards the shore, then halt, and the boat weighs 40 pounds. So that's nice that the boat is exactly 4 times heavier than the dog. We'll use that at the end to check what's going on. I'm going to just mark some spots. So I'm going to say this is the center of mass of the boat. So that's the position of the boat right there. The dog, of course, is 20 feet. I'm going to call this little distance from the dog to the center mass of the boat L. So it doesn't tell us how big the boat is, and hopefully it doesn't matter. So that term L should cancel out later, and I don't think it would matter. Okay, so we know that the dog moves relative to the boat. So that's a key little thing. So let's write some stuff down about that first. That the change in position of the dog relative to the boat, that's the 8.5. But I got to put the boat's motion in terms of that. Well, using our Galilean transformations, the change in position of the dog to the shore plus the change in position of the shore to the boat, those vectors should add up to the previous one, right? Where's my little pointer? Is it this? So this. So that dog to the boat is equal to the dog to the shore plus the shore of the boat. So hopefully you remember that from your transformation of coordinates. So what else can we say here? Then this change of position of the dog to the shore, that's the position of the dog at the end. I'm going to call that 2, minus the position of the dog at the beginning, 1. And that 1 I know is 20. Then I'm going to actually subtract here, right, because this would be the change in position of the boat to the shore. So the boat to the shore is opposite of the shore of the boat. Now we know this over here, the dog to the boat, that's minus 8.5 because I'm taking positive to be to the right. And let's finish filling this out. So the position of the dog to the shore 2, that's what we're looking for. Minus position 1, that's 20. Minus the change in position of the boat to the shore. So that is the boat to the shore at the end. So position of boat 2, that's at the end, minus position 1. Now that position 1, that's this one, that is the 20 minus L. Minus 20 minus L. All right, and all that's that. So that's good because we're now going to we need dog, and we're going to get dog in terms of boat here. So I'm just going to rearrange this for, I want to find XD, so I want to get what is XB, what is the boat in terms. So first let's distribute all this BS. There's the dog too, that's what I'm looking for, minus 20, minus, distribute this minus, and then distribute that minus the boat, plus 20 minus L, right? That's negative 8.5. All right, I want the boat to, so now the whole reason I'm doing this is because I need to put the boat's position in terms of the dog's position. And what I know is that the dog moved on the boat. So I know that 8.5. So I've got to find how much everything changed elsewhere. And that's why we use this Gaussian transformation. And this gives me so this 20 and 20, that cancels out. That's nice. Yeah, because that really shouldn't matter. Like how far you are from the shore. I don't know. At the beginning. Then we got to get this boat. So that comes over here. X boat 2 is going to be X dog 2 plus 8.5 minus the L. All right. Now I got to do the center of mass stuff. So that's just figuring out how the dog and the boat move relative to each other. And there's an easier way to do this when you know how things move when they're proportional masses. And I'll go over that at the end. So now we want to go to the center of mass stuff. So the position of the center of mass is the position of the dog, mass of the dog, plus the position of the boat, mass of the boat, divided by mass of the dog plus mass of the boat. And that center mass is not going to change. So if this is ones, that's going to equal position dog 2, mass dog plus position boat 2, mass boat over mass of the dog plus mass of the boat. Well, that denominator is the same, so that doesn't matter. So now I can put in everything I know up here. And so dog originally, that's 20. Mass of the dog's 10. I'm going to simplify that in a minute. Position of the boat originally was 20 minus L. Mass of the boat's 40. That's going to equal position of the dog, that's what I'm looking for, dog 2. Mass of the dog, 10. Plus position of the boat, but I've got that here in terms of the dog. What I want is my little highlighter. No, cancel. So, right here, right, we've got the boat in terms of the dog. So I'm going to put that down here, right there for my boat. So rather than that XB, I'm putting all this crap. And that's X of the dog 2 plus 8.5 minus L times 40. Now that's a 10, a 40, a 10, a 40. I can just divide everything by 10. So now I got 20 plus, distribute that, 80 minus 4L equals X of the dog 2 times 1 plus 4X of the dog 2 plus 4 times 8.5 is 34. 34 minus 4L. There's a 4L, right? There's a 4L, there's a 4L. The L does not matter. Fantastic. And now we just do a bunch of algebra, find out what X of the dog is. So we got 5X of the dog. Over here we got 100 minus 34. 100 minus 34 is what? 66. 66 equals 5X of the dog. So 66 over 5. X of the dog 2. So that's our answer. I think that's like 13. 12 to 6 is 13. 13 and 1/5, 13.2. 13.2 feet. That's where it is now. Now, you could have just done this like transformation things up here to figure it out. Because the boat is 40 and the dog is 10, you know the boat is going to move 1/4 as much as the dog is going to move, or the dog will move 4 times as far. So you know this change position of dog to the shore, this right there, that is going to be 4 times bigger than the change in the boat to the shore. So you know that those changes relative to the shore, the boat will move 1/4 as much, or the dog will move 4 times as much. So knowing that relationship, you could plug that into this transformation and figure out the position of the dog at the end from that, because you know the boat will move 1/4 as much. And I'm not going to go through that, but that would give you the same answer. Give you 13.2 rather. All right, there's that one.